Good morning everyone. This is the second video of the chapter 3, metal and non-metals. In the previous video we have discussed about the definitions of metals and non-metals and their physical properties like malleability, ductility, luster, melting point, boiling point, hardness, sonoricity with their exceptions. Today we will discuss about chemical properties of metal and non-metal. Chemical properties of metal and non-metal. Basically, metals reacts with air, water, so acid and base. Chemical properties of metals. Metals reacts with four components: air, water, acid and base. When metal reacts with air, there are five components of air. If we consider air or oxygen, when metal reacts with oxygen to form metal oxide. Metal reacts with water to form metal hydroxide or oxide. Metal hydroxide or oxide along with liberation of hydrogen gas. Next is metal when reacts with acid, it forms metal salt. Salt of the metal and hydrogen gas is liberated here also. When metal reacts with base, here also salt is formed, but this metal salt is complex salts, not simple salts. As we discussed in the first chapter, that there are different types of salts in previous chapter, acid, bases and salts. There are different types of salts, simple salts and complex salts. So when some metal react with base means alkalis to form salt and hydrogen gas. Here, in three cases, with water, with acid and with base, always hydrogen gas is formed. This hydrogen gas is formed. Hydrogen gas is formed. So, you must remember these three. In your question, you have to mention that which gas is evolved when metal react with water, when metal react with acid or when metal reacts with base, and how do you confirm by your test. Let's start from the reaction of metal with air. Metal plus air. Metal plus air. Different type of substances formed. If air component of air is oxygen, nitrogen, carbon dioxide, water and other gases, argon and other gases. Then what happens when a metal reacts with oxygen? The metal oxides are formed. Some reactive metal also reacts with nitrogen. Nitrogen is an inert gas, but sometimes it reacts with metals like sodium, magnesium. Carbon dioxide, it is present in very small amount in air, but if a metal reacts with carbon dioxide, then carbonate is formed. And when water reacts with water, we will discuss reaction of metal with water in a separate discussion. So let's start with reaction of metal with oxygen. Metal plus oxygen. Metal oxide plus only metal oxide is formed. This metal oxide is generally basic in nature with some exceptions like alphotric oxide, zinc oxide, aluminum oxide, lead oxide, etc. Metal with when sodium reacts with, for example, when sodium reacts with oxygen, sodium oxide is formed. When magnesium, you know that to react with sodium, we only has to expose this sodium metal in air. We kept this sodium metal in kerosene because when sodium is exposed to air, it starts burning. It starts reacting with oxygen. So, when sodium reacts with oxygen, sodium oxide is formed. It may burn. This sodium oxide starts burning, or so this reaction is exothermic reaction. Likewise, potassium also, potassium plus oxygen, then potassium oxide is formed, and this is also exothermic. When in the reactivity series, when potassium sodium, after potassium sodium there is calcium. When calcium reacts with oxygen, it is less vigorous. It is not highly vigorous. So calcium oxide is formed, but this is not an exothermic reaction. These two reactions are exothermic. Next, how do you react magnesium ribbon to oxygen? We have to remove the magnesium oxide layer from the magnesium ribbon, and then we have to heat the magnesium to burn with oxygen, and it burns with a dazzling white light. So here energy is needed here, magnesium to form magnesium oxide. This magnesium oxide is white in color and it burns with a dazzling white light. Now, these four oxides are basic in nature. These are basic oxides. How these are basic oxides? To understand these, let's start with the reaction of these oxides with water. These oxides with water. When sodium oxide reacts with water, it forms sodium hydroxide. When potassium reacts with water, it forms potassium hydroxide. And these two are also, the reaction of these two are also, these three are basically are also exothermic reaction. You know this reaction, when quicklime when reacts with water, it forms calcium hydroxide, and these three reactions are exothermic. But with magnesium oxide, we already dissolved the magnesium oxide, which is white ash of magnesium oxide with water. So it not readily dissolved in water. This is magnesium hydroxide is formed here, but it is not exothermic. It is slow reaction. This reaction is slow. So magnesium hydroxide is not a strong base. Next is reaction of some metal oxides are, these metal oxides are basic in nature, but some metal oxides are amphoteric in nature. Are amphoteric oxides. Some metal oxides which acts both as an acid or a base. You know very well, we have already discussed this amphoteric oxide in the previous chapter, acid, bases and salt. So examples of this amphoteric oxide are zinc oxide, aluminum oxide, lead oxide, etc. Next is reaction of metal with, next component of here, reaction of metal with nitrogen. Some reactive metal react with nitrogen. So give an example of magnesium. Magnesium plus nitrogen forms magnesium nitride. To write the magnesium nitride, you have to crisscross the valencies of these two elements. Magnesium is, the valency of magnesium is 2, so nitrogen 2, and the valency of nitrogen is 3, so magnesium 3. This is magnesium nitride. So this is complete reaction of metal with air. Metal with air. Air means oxygen. To form non-metallic oxide, and this non-metallic oxide is acidic in nature. For example, C plus O2, CO2 and S plus O2. Sometimes it is SO2, and when this SO2 also reacts with oxygen, they form SO3. So sometimes it is SO2 or SO3. Phosphorus plus oxygen, P2O5, phosphorus pentoxide. P4, balance this reaction by adding 2 here. P5. Non-metal oxides, these oxides are acidic in nature. Acidic. So when this CO2 reacts with water, how do you test that these oxides are acidic in nature? Take a litmus paper, moisten it, and then put it on these gases. So when carbon dioxide reacts with water, it forms carbonic acid. When SO2 reacts with water, H2SO3, sulfurous acid, and when SO3 reacts with water, then sulfuric acid is formed. When P2O5 reacts with water, phosphoric acid or phosphoric acid is formed. So according to these reactions, we can say that these oxides are acidic in nature. Next reaction is reaction of metal with water. Non-metal doesn't react with water. So start from the non-metal. First write the reaction of, this is second reaction. Reaction of metal and non-metal, metals and non-metals with water. Note that non-metals do not react with water. As if you put a piece of coal in water, there is no reaction between carbon and water. Here is a question that why phosphorus is kept under water. Phosphorus is a non-metal. And it doesn't react with water. So, and phosphorus, when exposed to air, it starts burning. So we put the phosphorus in water. There is no reaction between this. Next reaction is reaction of metal with water. To understand this reaction, you must remember the reactivity series. Here I am going to write the reactivity series. as you know that in the reactivity series, the first element is potassium, then sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, hydrogen, copper, mercury, silver, gold and platinum. This is the decreasing reactivity. Decreasing reactivity. The most reactive is potassium and the least reactive is platinum. So when this potassium reacts with water, it reacts vigorously to form potassium hydroxide plus heat is evolved. It is also an exothermic reaction. The amount of heat is very high that in this reaction, if hydrogen is liberated, it starts burning. Due to this heat, the hydrogen starts burning. So this is a highly exothermic reaction. Likewise, when sodium reacts with water, the reaction is also vigorous. As you all know, when we put a piece of sodium into water, it starts burning due to burning of this hydrogen gas. So these two reactions are highly exothermic. When calcium reacts with water, it is not an exothermic reaction. Calcium just reacts with water to form calcium hydroxide along with hydrogen. But the amount of heat energy liberated here is not enough to burn this hydrogen gas. If we go to the reactivity series downward, then this vigorous reaction, the intensity of the reaction decreases. This is also an exothermic reaction, but the amount of heat is not enough to burn this hydrogen gas. If we want to react magnesium, a small amount of magnesium ribbon and then add it to the water, this reaction is not vigorous. We must need a warm water here. To form magnesium hydroxide, we need warm water and hydrogen gas is formed in this. With aluminium, here from aluminium, when it requires steam or hot water. With hot water, aluminium not form aluminium hydroxide, it forms aluminium oxide along with hydrogen gas. With zinc, we also need hot water to form zinc oxide or steam. We need steam or hot water to react zinc with water. Zinc oxide plus hydrogen gas. Here also hydroxide is not formed. With iron, we need steam. Iron reacts with the steam to form ferric oxide along with liberation of hydrogen gas. These reactions are not exothermic reaction. Likewise, tin, lead when reacts with steam, iron, tin and lead when reacts with steam, they form their corresponding oxide, tin oxide, lead oxide along with water. Copper, mercury, silver, gold doesn't react with water. There is no reaction. So, to understand this reaction, you must understand the reactivity, you must learn the reactivity series. And next reaction is, this is reaction of metal with water. In these reactions, most highly reactive element form hydroxide and lesser reactive element, moderate reactive element forms oxide. Non-metal doesn't react with water. So our next reaction is third reaction is reaction of metal with acid. As we discussed the reaction of metal with acid in acid bases and salt chapter, so take a quick revision of it.